Geotesting as an incrementality testing approach is having its moment under the sun. It is emerging as the most popular testing approach in the marketing world as we speak. In this video, let us try to understand experiments in much more detail, and we will focus this explainer primarily on geotesting. However, the concepts are generalizable to customer level testing or to understand testing in general as well. Why is geotesting gaining in popularity? 1. It's an identity-agnostic way of doing measurements. 2. It offers a common framework to compare different channels or tactics, which is not possible in customer-level testing or other live studies offered by ad platforms. If you want to compare Google PMax with Facebook prospecting, you should use the same measuring stick on both of them. This is possible with geotesting. 3. Certain new algorithms such as synthetic control method and power analysis-based market selection offer robust ways to arrive at the right statistical power of the experiments and define counterfactuals. Now, let me take you through the process of geotesting over these 6 steps. Step 1. We start with the hypothesis that we want to test. Are we trying to prove that the incremental ROAS of a particular channel or tactic or creative strategy is at least 1x or 3x? Or are we trying to prove the cost of acquiring a new install or a new order is say $100 or $200? Earlier, we spoke about 2 types of hypotheses that go into any test, null and the alternatives. In the case of geotesting, the null hypothesis is that the intervention that you're going to make as part of the test won't create any meaningful or significant difference between the treatment and the control group. Alternative hypothesis could point to a one-way or a two-way test. The standard practice is to perform a one-way test because our primary objective is to prove that there is an increase in lift from a scale-up test or a decrease in lift from a holdout test, both of which are favorable outcomes from the perspective of the channel or tactic that is getting tested. In step 2, we look at the historical data of the outcome that we want to measure, such as installs, revenue, new customers, new orders, and so on, at various geography levels, such as state, city, DMA, or postcode. Step 3. Based on the historical data, we randomly pick a few treatment clusters of geographies of predefined cluster size ranges and perform power analysis. We spoke about statistical power in the previous video. Statistical power is the probability that a statistical test will correctly detect a real effect or difference when it exists, also known as the ability to avoid a type 2 error, that is, falsely failing to reject the null hypothesis. Power analysis is the technique to essentially ensure that the test we are designing has good statistical power. We will revisit power analysis shortly and go through the steps involved in power analysis in greater detail. This brings us to step number 4. We take a look at the result of the power analysis and then pick the treatment cluster to initiate the test. What you see on the screen is a sample of all the test market clusters based on various metrics as generated by power analysis. Here, power analysis is run for a bunch of 2-state test markets for scale-up geotesting. For every test market cluster, we can see these metrics computed. The duration in days or weeks for which the test should be run. Additional spend required for testing as part of scale-up. MDL or minimum detectable lift. That is the smallest percentage change in performance that can be reliably detected by this experiment. Estimated lift, which is the predicted improvement in performance compared to the control markets. ASLI or absolute scale L2 imbalance, which is a number between 0 and 1 that helps us understand how much the control market matches with the test markets before the experiment. Lower the imbalance, the better. Estimated bias, which is the estimated lift while simulating 0% true lift. Value close to 0 suggests better market selection. We'll talk about the steps through which power analysis happens, and this will make the concept of simulation mentioned here a lot more clearer. So based on all these metrics, one could pick the test markets based on a few high-level criteria. Pick the market with the lowest market share so as to minimize the opportunity cost. Or pick the markets with the highest power, which in this case is a combination of low bias and imbalance and high MDL and estimated lift. Or pick a test which has a duration that you're comfortable with without compromising much on the power. In step 5, we pick the test markets and deploy the test, which could be either scale up or hold up. A lot of marketers look for seamless deployment of tests. As a unified marketing measurements vector, we put in a lot of effort in automated deployment of incrementality experiments besides the design of them. However, deployment of the test is an operationalization step. The ultimate quality of the test depends primarily on the scientific rigor of its design. In step 6, we refresh experiments with new data. This typically happens towards the end of the test duration, and we look at the lift numbers. Power analysis is the core of a good experiment design. Let us look under the hood of a power analysis and see how it happens. The details mentioned here are specific to how Lifesight goes about doing power analysis. In Lifesight's approach to power analysis, we take each potential set of test markets and run them through a series of synthetic experiments. For each market combination, we perform these steps. Step 1, we simulate multiple treatment durations. We test how the experiment would perform if run for different lengths of time. This helps determine the optimal experiment duration. Step 2, apply various effect sizes. We simulate the different potential lift scenarios by applying effect sizes from the specified range. Example, minus 20% to plus 20% in 5% increments. This allows us to understand how sensitive each market combination is to different magnitudes of impact. Step 3, construct synthetic controls. For each test scenario, we use augmented synthetic control methodology to create a counterfactual. This technique builds a weighted combination of control markets that best mimics the pre-experiment behavior of test markets. This image that you see is an example where, for a particular set of treatment markets, our synthetic control markets is as listed. As you can see, the synthetic control is a list of weighted combinations of a few other states or markets. This approach to defining control markets offers a lot of advantages over the regular, naive, market matching approach that's traditionally practiced for geotesting. Here we are able to create the control group programmatically so as to make it very close to the treatment market in terms of its relation to the business. This way, we can reduce the bias and imbalance in the test. This approach also makes the test more robust to confounders and other disruptions in the control markets. Remember, we discussed in the earlier video about causal MMM that unknown confounders is one of the biggest challenges in performing causal inference on observational data. However, in geotesting, we get to be smart in a way of creating control groups so as to nullify or minimize the impact of confounders on the analysis. Step 4, calculate treatment effects. For each simulated scenario, we estimate the average treatment effect, that is ATE. Compute p-values to determine statistical significance and generate confidence intervals along with bias, scaled L2 imbalance, and so on. Step 5. In this step, we finally determine the power and minimum detectable effect. By running multiple simulations, we calculate the proportion of times an effect was detected, that is statistical power, identify the smallest effect size that can be reliably detected with at least 80% power, and evaluate how accurately the model recovers the true simulated effect. So that's all about geotesting. Here, the test elements were geographies. That is, the randomization was done at geography level. We could do this also at customer level and create the testing and control group by splitting similar customer segments into two cohorts. However, as we saw with geotesting, it's a lot more scientific to look at historical data to prepare better synthetic control groups in geotesting rather than creating control groups at customer level. Also, customer split testing still happens within the targeting or retargeting black box of the ad platforms, which makes it difficult for us to properly normalize the lift numbers across the treatment and control groups. Let us now go through a list of frequently asked questions about geotesting. 1. How much data is required for market selection and power analysis? The purpose of power analysis, as we already saw, is to primarily identify the most robust counterfactual, the right test duration, and the right spend levels, so as to make significant inferences from the test. To be able to create the best synthetic counterfactual, more data is better. The recommended lookback is for 2 years. 2 years of data also has a lot of context about seasonality, which will help us make very accurate estimates of estimated bias and L2 imbalance. For businesses that do not have a lot of seasonal variations in them, even 6 months of data could suffice for market selection. 2. When to do holdout testing and when to do scale-up testing. There are some rules of thumb here. A new channel should always go through a scale-up testing process. This also applies to channels which have had relatively lower share of spend in the treatment period. Such channels will need to be significantly scaled up in the treatment geographies so that they have a chance to find healthy MDL. For major channels, that's channels which have had significant share of spend in the pre-treatment period, holdout test is recommended. Holdout tests are easier to deploy and control for compared to scale-up tests. It's also recommended that you run your hypotheses against both scale-up and holdout power analysis wherever required and evaluate the powers across both options to decide the best one. Third question, does positive lift always mean high incrementality? Not necessarily. Lift as reported by geo-testing means that your intervention has created a positive outcome on the treatment geographies vis-a-vis the control geographies. The positive outcome for a scale-up test is a positive lift above the MDL, and the positive outcome for a holdout test is a negative lift. We need to then translate these lift numbers to incremental ROAS or incremental CAC and see if it's better than our benchmark of what it means to be efficient from within our marketing context. 4. What to do for channels that are not geo-testable or channels that are not randomizable in any way. This is the scenario where we need to rely on time as a test element. While geography level testing randomizes across geographies to create treatment and control groups, and customer level testing does the same on customer segments, time level testing compares interventions across separate periods of time. Here, we need to first establish a counterfactual using a very robust forecasting model and then test the impact of the intervention against the forecasted counterfactual. Time testing is an approach that's easier to deploy compared to geo-testing or customer level testing. However, statistically, it's a lot more complex. Remember the fundamental problem of causal inference. That is, counterfactuals are not really observable in the real world. We need to have a very accurate way of defining counterfactuals so as to make accurate inference from it. At Lifesight, we are building a time testing approach that relies on a causal forecasting system to define the counterfactual. This, we believe, offers a lot of advantages over other time series discontinuity or regression discontinuity based causal impact or time testing estimates. Lifesight's causal forecasting is powered by the underlying causal MMM models. So if we can evaluate the result of the intervention against the expected numbers from the MMM models, it offers a better calibration feedback back into the models, making this a virtuous cycle of model creation, forecasting, and calibration. So those were some of the frequently asked questions about incrementality testing. If you have more questions, kindly reach out to us. We'll help you get answers to all your questions. In the whole spectrum of techniques available under the umbrella of unified marketing measurements, experiments are the most rigorous and accurate way to get your incrementality reads, but it is also the slowest. However, we urge every marketer to adopt both causal models and controlled experiments to build a very strong measurement foundation powered by incrementality and causal reasoning for your brands.